Hey everybody, we're going to take a look at chapter 14. Now we're doing chapter 14 in two parts, so I'm going to have you do some reading out of the textbook, and if you look online there are some questions there as well as in your course pack that'll have you look at one section of chapter 14, mostly the first part of that, and there's a lot to cover there, and I think a lot of it's important, and so I think it's better to have you read through that. Now of course I'd be happy to answer any questions there, but I try and make those questions in the review section pretty straightforward so that you can kind of just focus on some of the basic concepts of the immune system. So with the first part of chapter 14, you're looking at a lot of things that are based on anatomy and physiology, some of the physical barriers to infection. We'll kind of go over that here in just a second in a little more detail. And then towards the middle, you're looking at some of the ways that these body systems connect to each other, how the bloodstream and the lymphatic system overlap, for example. And then towards the end, which is what we're going to look at here in more detail, we're looking at some of the different cell types and some of the different types of immune responses and how they work on a more in-depth level. So kind of do it in two parts, and the textbook is going to cover some of the basics there. Okay, so if you haven't read that already, I suggest that you do that first, although it's not 100% required either way, but ideally you probably want to read the textbook questions first, answer the textbook questions, that is, by reading, and then come take a look at the video. So think about doing that if you haven't. Okay, so when we're looking at chapter 14 here, we're taking a look at some of the, as I titled it here, some of the details of innate immunity. Okay, so this is building on that foundation in the textbook here. So first of all, before I get into the PowerPoints here, I want to outline just a few things here. So when we look at our immune system, it's really a three-tier system, or what we call the 3 levels of defense. Okay, so 3 levels of defense, and I'm going to put that in quotes, partly because when I say defense, that's kind of a broad thing. Also because it's described differently in different textbooks, different sources, different textbooks, different individuals will sometimes describe these a little bit differently. So the first part, the first level, so to speak, is actually not part of the immune system, and this is why we call them the levels of defense as opposed to the 3 levels of the immune system, because really the defense itself as a whole partly involves the immune system, but it also involves what we refer to as barriers to infection. This is actually not technically part of the immune system. It's actually part of the anatomy and the physiology of the body. The way the body has been kind of constructed to prevent microbes from getting in, and really trying to at the very least, keeping the threshold of microbes down. Recall from chapter 13, we talked about the infectious dose, the minimum number of microbes needed to establish and cause infection. And really, one of the ways that the body reduces that is by simply blocking them from actually getting in and from attaching and from establishing at that minimum level that's often required. So barriers to infection. I always like to put a little side note below each one of these, and I like to just refer to this as AMP, anatomy and physiology, as it has to do with the natural, as I mentioned, anatomical and physiological structures your body uses. Again, not technically not part of the immune system. Okay, so speaking technically, this is not actually part of that system. And again, the book goes over this in more detail. We really won't touch on that here in the PowerPoint. It's really going to be something you read about. Now, the second level of defense does start into the immune system. This is technically where the immune system begins. And the second level is often referred to as the non-specific immune response. And it's also referred to as the innate immune response, innate immunity, I should say. That's how I have it titled on the PowerPoint. I'm giving it to you in both ways because you'll hear it described in both ways. So it's sometimes referred to as non-specific, sometimes referred to as innate. In general, the best way to think about this level of the immune system is that the body is responding to typically foreign microbes, although you get into allergies and all sorts of weird kind of ancillary reactions, but typically to a foreign microbe, either a virus or bacteria or fungi, protozoa. Those are the sometimes helminths, so 10 of 5 typical things there. And the way it typically works at this level is that the body is responding from a quote-unquote self versus non-self basis. And this is largely based on protein receptors on every cell. Every cell has a series of proteins on the outside of it. Let me just show this here. So here's a cell. And every cell has a variety of little proteins that stick up out of the membrane. And they have a complex three-dimensional shape. And if you were to zoom in and look at an actual cell and look at these in great detail, you'd find that they have really elaborate three-dimensional shapes. And the totality of these are the equivalent to like a facial feature. So the way that these look can be kind of thought of as like a face and all the different subtle characteristics of a face. And the way the immune system works is that it often determines what is part of the body versus what is not part of the body. So again, self versus non-self, determines that to a certain degree based on the nature of these receptors. So for example, your body, just do a real basic drawing here, your body has cells that will have very specific receptors that are identical to your own body. So they might look like a kind of a triangle shape, something like that here. Okay, obviously, to clarify, they don't actually look like that at all, but that's something that would be, you would have a unique shape to it. So that might be what your body's receptors look like. And then if we were to look at a foreign invading microbe, it might have receptors that maybe have a very different shape. Perhaps they look more like this, whatever shape that is, I don't even know. Okay, and so the idea is that each different cell will have a slightly different receptor, or a series of them really. They're really not actually a receptor, they're actually we call it a cell identifying marker, or an ID tag. But every cell has their own unique one, and the body will determine its own from that of foreign or non-self entities. And in this general sense, then, the body can kind of differentiate itself from other microbes. Now, it does this in a very kind of discriminatory way. It looks at its own receptors and determines that they are of the body, and anything else that doesn't match those to a certain degree can be considered foreign. Now, there's more to it than that, so I'm generalizing quite a bit here. But in a sense, that's kind of how it works. You either have the matching or you don't, and therefore you're either part of the self or the non-self. And so we'll talk about it a little bit more. These are an example, give you a heads up here of what is often considered non-self or referred to as PAMPs. And these are facial or cell characteristics that are found in certain types of pathogens. So they're often a very immediate type of receptor there, or receptor rather, that triggers an immediate response by the immune system. Okay, so that's the second level. Let me give you an example of that, then we'll move on past this here. An example of what often carries out this self versus non-self determination, or something that we've talked about already, and these are phagocytes. Phagocytes are the cells that engulf and swallow foreign particles and foreign microbes, and they're often doing that based on a self versus non-self basis. So they travel throughout the body, if something looks foreign, they swallow it and they kill it, and if not, they leave it alone. There's other aspects to that. That is just an example, not the entirety of the second line, just one example. Okay, now the third line of your immune system involves a very different set of cells that make up what's called the specific immunity, or the specific immune response, that is. And these can be thought of in addition. Move this stuff around here. Just go ahead and delete these. These are often referred to, kind of like we have two names for this. The other way to think about these is part of the adaptive immunity. Now, the way this works is you have cells called B and T lymphocytes. And the term lymphocyte is just a fancy term for cells. So these are more commonly referred to as B and T cells. Same thing as a lymphocyte, just that's the more technical name for it, lymphocyte. So these are both part of the specific immune response. And the way that these work is that you have billions, literally billions upon billions of specific types of B and T cells, and each one will respond to a particular what's called antigen. So in this particular case, rather than responding on a self versus non-self, so everything's either part of the body or it's foreign, in this case each cell will recognize one particular type of foreign particle or foreign microbe. And the term is called an antigen. We'll talk about this. And by the way, this is actually the topic of chapter 15. So let me make a little side note here. This here is really what we're going to get into more detail when it comes to chapter 15. So I'm going to kind of keep this part of it brief here because we'll come back and spend more time on that now. So I'm just kind of giving you the overview, and so that we can kind of make more sense of it all. So this right here really is part of 14. Actually, kind of both of these here are part of 14. So B and T lymphocytes, each one will recognize a particular type of foreign entity and will respond to it on an individual case-by-case basis. So if you think about it, the second line is kind of like a general task force that's looking for anything considered quote-unquote bad. Almost like your kind of police force in the neighborhood or your local police force. They're just kind of there to take care of any sort of threat, whether it's a domestic threat or whether it's a robbery or whether it's could be a variety of different things. They're speeding, etc. Any kind of general threat they'd be there to take care of. The specific immune response is almost like the FBI or a more advanced level of a crime force agency. And what they're doing is they're looking at things on a case-by-case basis, and they're going after person X or person Y, and they're not necessarily just out there policing on a general basis. They're actually looking at a list of individuals who've done things specifically, and they're each part of that task force is looking at individuals on a case-by-case basis. That's kind of like how the third line of the immune system works. Each cell is delegated to one particular task, and as an overall whole, each cell is kind of taking care of individual foreign threats, and they all kind of work collectively as a whole. The other part of this are what are called antibodies. Antibodies are little protein molecules that are actually produced specifically by the B lymphocytes themselves. So these are the two cell types involved, and the B cells produce these acellular molecules called antibodies. And antibodies often have kind of a Y shape to them, and they tend to have they have an ability to attack pathogens and foreign particles without any connection to a cell. So B and T lymphocytes either actually like a cellular force, and these are just basically a protein that can attack molecules independently of other cells. So again, hopefully this will all make sense when we get to chapter 15. So anyway, that's your three levels. I wanted to give you an overview here of what these look like. So it starts with a barrier to infection, try and keep things out. It gets into a non-specific response where the body's kind of responding in very general terms, self versus non-self. And then anything that makes it past that will ultimately get into the third line where we have specific cells that are going to trigger specific types of responses. Okay, so let's take a look at the PowerPoint now. This is the first slide here after the title page. So here I'm referring to it as innate immunity. So we're starting with the second line of defense, and this is one more reminder. The first part is going to be discussed in the textbook, and it also touches on this as well, but we're going in more detail here. So once a microbe gets past the barriers to infection, the mucus, the skin, the different non-specific chemicals such as sebum and lysosome, all these things that the body has to kind of prevent microbes from getting in. If any microbe makes it past that, and eventually they will, then at some point they're going to run into different aspects of the second line. So these include things like phagocytes. Phagocytes exhibit phagocytosis, which is the action that they exhibit, whereas the phagocyte is the cell itself. So they'll run into phagocytes. They will trigger inflammatory events. Inflammation can lead to fever, and there's also a cascade series of, a variety of different what are called antimicrobial proteins. So these are kind of acellular immune components that will attack and try and ward off various invading microbes. So really, it's a whole series of reactions that all kind of work together. And I mentioned that it's kind of like a police force, and just like a police force, you have different parts of that. You have the sheriff versus the deputies versus the you can tell I don't really know my police force levels here, but anyway, you have different levels, kind of like you have at any agency, and this is kind of the same thing with your innate immunity. So one of the most common is phagocytes that exhibit phagocytosis. So these are typically one of the first components of the second line that foreign microbes and another, typically a living microbe like a bacteria or fungi, these are typically the first things that they're going to run into here. And we really have a variety of phagocytes. I've mentioned them so far as kind of one particular thing, like they all are the same, and the truth is they're not. There's actually a variety of them, and when we look at it in this chapter, we'll kind of break down those different variations. So the most common are what are called neutrophils, and then we have other cells called monocytes, and monocytes will actually develop into what are called macrophages, and then we'll actually see that we have different types of macrophages. So each one is capable of phagocytosis, the ingestion and swallowing and digestion of a foreign microbe, but each one is a little different, has their own characteristics. Now, as a whole, each one has really three general things that it's doing. And the first is surveying, and this is where the self versus non-self determination comes in. So they're surveying the body, and they're looking for anything that is determined to be non-self. And if it matches this kind of non-self description, then they will start to phagocytize it. Now, the immune system is very complicated, and we're really kind of talking about it in specific terms. If you notice here, it also says that they will look for particulate matter, injured or dead cells. So even in the case of the self, they can determine whether a cell is dead or otherwise basically on the way out, dying, injured, and they can actually determine that through different mechanisms and can be partly responsible for phagocytizing those as well. And that's a whole kind of a different part of the immune system. So we're really kind of focusing on the basics of it here in terms of how they survey microbes. So once they recognize a microbe as being foreign, then they will, and that actually gets into the recognition here. So really surveying, to clarify, involves kind of migrating throughout the tissue. Recognization, or recognizing, involves the self versus non-self determination. And then finally, the actual act of phagocytizing, which is ingestion and elimination of that particular microbe or particulate matter. Neutrophils, as I mentioned, are one of the most common, and neutrophils they make up something like 60 to 90% of all circulating white blood cells, just white blood cells in general. So they're very, very common. Really, if you think about the immune system as like a military force, then these are kind of like the basic infantry, and they tend to have the largest presence. And they also tend to have kind of a general role, not a great amount of specialization here. So typically a foreign microbe is going to run into these first in most cases. And so they're early in the inflammatory response to bacteria, foreign materials, and damaged tissue. Typically a sign of a bacterial infection is that you have a high neutrophil count in the blood. Excuse me. A much less common but also kind of general type of phagocyte are called eosinophils. And they tend to play a role when it comes to parasitic worm infections, as an example. So it says attracted to sites of parasitic infection, and this mostly talking about parasitic worms, although protozoa could also elicit the response. They tend to be attracted to certain types of infections like parasitic worms, and they often have a much more prominent role in that type of infection. They also play roles in what are called antigen-antibody reactions, which is something that we'll talk about later when it comes to chapter 15 and chapter 16. We'll talk about disorders of the immune system. So these are both kind of very general types of phagocytes, neutrophils being the most common, and eosinophils being a type that would respond to certain types of infections, worm infections as an example.